June 5, 1976, a canyon on the Teton River in eastern Idaho. Two men on bulldozers are driving out onto the face of a brand new dam, trying to plug a hole with dirt. The dam is 305 feet tall. It was finished 7 months ago. It has never held a full reservoir before, and after today it never will again. Behind it sits about 80 billion gallons of snowmelt. In front of the dozers, a dark wet stain is spreading down the embankment, and it's getting wider while they watch. Here's what's hard to explain. Nobody should have been surprised by that water. Engineers already knew the rock under this canyon leaked. They had pumped roughly 600,000 cubic feet of grout into it, trying to seal it shut. Then they drilled back in to check their work, and the rock came out just as broken as before. They filled it anyway, faster than their own rules allowed. So who kept filling it? Stay with me. The dam spent 2 days answering that question. Eastern Idaho had wanted this dam for most of a century. The Teton River ran hard in spring and thin by August, which is the worst possible rhythm for a farm. Floods in June, dust by harvest. So the Bureau of Reclamation went into the canyon to fix the river's schedule. What they built was an earthfill dam. Not concrete, earth. A wall of compacted soil 305 feet high, stretched right across the canyon, with a dense waterproof core buried down the middle of it like a spine. That core was the entire design. Everything else was weight holding the core in place. Construction finished in November of 1975. On paper, it was a clean success. Flood control, irrigation water, and power, all pulled out of a river that had been useless half of every year. The reservoir began filling that autumn. That was the first moment anybody would learn whether this canyon could actually hold water. That's how a first fill works on every dam ever built. Test and the disaster are the same event. The trouble started 2 million years ago with a volcano. The canyon walls at the dam site are welded volcanic ash. Ash blown out of the Yellowstone system and fused solid by its own heat. Rock like that cracks as it cools, and it cracks badly. What's left is stone shot through with vertical joints, open fissures, and loose rubble zones. One engineer put it best, essentially Swiss cheese. None of this was a secret. Drillers kept finding voids. A geologist with the United States Geological Survey, David Schleicher, put his concerns in a memo, warning that those jointed ash flows would let reservoir water travel straight around the structure. Think about what that actually means. A dam isn't just the wall. A dam is the wall plus the ground it stands in. If water can walk through the ground, the wall is decoration. The Bureau's answer was not to move the dam. It was to seal the canyon. They would pump cement into every crack in that rock until the leaking stone went watertight. They tried. Watch what happened. Grouting means drilling into rock and pumping cement slurry down the hole under pressure until the cracks fill and the flow stops. On ordinary fractured rock, it works. Teton was not ordinary rock. A pilot test suggested the foundation would take about 260,000 cubic feet of grout. The real curtain took more than double that. 3 rows of drilled holes swallowed close to 600,000 cubic feet, vanishing into a canyon that never seemed to fill up. That's a warning all by itself. When rock takes twice the grout you predicted, your picture of that rock is wrong. Then came the check. Crews pulled core samples back out through the grouted zone to see what they had achieved. The rock came up just as broken, just as fractured, and just as porous as before. There was a second gap too. The slush grouting meant to seal the raw rock surface inside the key trench simply stopped once crews reached elevation 5200. The investigation afterward could not explain why. Above that line, the rock under the dam's core was never sealed at all. Now the core itself, this is the part that decides everything. Down the center line of the dam, they cut a deep key trench, then packed it full of wind-blown silt scraped off the uplands nearby. Fine, dry, dusty soil. It compacts beautifully and it holds water out, which is why they chose it. It also erodes about as easily as anything on Earth. The grains are too small to lock together the way sand and gravel do, and too big for the chemistry that binds real clay. One engineer's verdict on using it here is blunt. Practically the worst choice you could make for the core of an embankment dam. Then there's what wasn't built at all. A modern embankment dam carries a second line of defense behind the core, a graded filter of sand and gravel that catches escaping water and strips the soil out of it before it can carry the dam away. Teton had no filter. The design relied fully on the grout curtain and that trench of dust, one barrier, no backup. Standing in a canyon nobody had managed to seal. The winter of 1975 into 1976 buried the Tetons in snow. By spring, it was melting into the reservoir faster than anyone had planned for. Normally that's manageable because a dam has outlet works, gates and tunnels that let operators dump water downstream whenever they need to. At Teton, those weren't finished. The powerhouse, the auxiliary spillway, and the outlet works were all still under construction while the reservoir climbed behind them. There was no way to let water back out at anything like the rate it was coming in. So the filling schedule went out the window. The original limit was 1 foot of rise per day. In March of 1976, that was raised to 2. By the middle of May, the water was climbing about 3 feet a day, and at its fastest, 4.3. Read that back slowly. A dam standing in cracked volcanic rock with an erodible dust core and no filter behind it was being loaded 4 times faster than its own safety limit by people who no longer had a way to stop. Every foot of rise leaned harder on the one thing holding. On June 3rd, 2 small seeps appeared at the downstream toe of the dam. Clear water, barely a trickle, each running less than 1/4 of a cubic foot per second. Clear seepage usually means water moving through rock rather than through the dam, and it carries nothing away with it. Nobody panicked. Early on June 5th, that changed. Water was pouring out of the joints in the rock near the right abutment at 20 to 30 cubic feet per second. Then it turned muddy. That is the moment the dam died, and almost nobody watching knew it. Muddy water means the flow has found the core and is eating it, hauling the dam out through the hole grain by grain. Engineers call it piping. Once it starts, it feeds itself and it accelerates. By mid-morning, a sinkhole had opened on the downstream slope. Around 10:30, a muddy geyser blew out of the embankment face. 2 contractors ran bulldozers onto the dam and shoved dirt into the hole. One machine sank in and washed away. The second operator climbed onto another and kept pushing until 5 minutes before noon. Both men got off alive. Barely. At 11:57 in the morning, the north side of the embankment gave way. A local radio host named Don Ellis was broadcasting live from the canyon on KRXK. What he said was this: "The whole north side of the dam is caving in. What came through that gap is hard to picture, so take the numbers instead. The reservoir was holding roughly 260,000 acre-feet of water, about 80 billion gallons. Peak flow through the breach passed 1 million cubic feet per second. Within 6 hours, the entire reservoir was gone, not lowered, gone. And notice how it failed. The dam didn't crack, or topple, or slide down the canyon. It dissolved. The gap simply widened and kept widening because the thing doing the holding was a trench full of dry silt with a hole already running through it. 7 months of construction, 2 days of warning, 6 hours of water. Downstream, the valley had no idea what was coming. Some of it had about an hour. The town of Wilford sat about 12 miles down the canyon. The flood reached it, and Sugar City just beyond it, around 1 in the afternoon, as a wall of water roughly 15 feet high. In Wilford, 120 of the town's 154 homes were swept off their foundations, not damaged, gone. The leading edge hit Rexburg, 15 miles from the dam, at about 1:40. Rexburg had a lumber mill, and the flood picked the stacked timber up and drove it through town ahead of the water. More than 35,000 people were evacuated ahead of that wave. Warnings went out over the radio, down telephone lines, out of police cars, and off the knuckles of neighbors pounding on doors. That hour of warning is the single reason this isn't remembered as one of the worst disasters in American history. 11 people died. The water spread across 5 counties and more than 300 square miles and ran 155 miles downstream before the American Falls Reservoir swallowed it. It took roughly 100,000 acres of farmland and 32 miles of railroad with it. An hour saved a valley. It didn't save everyone. 2 investigations followed, one by an independent panel and one by the Bureau itself. They landed on the same mechanism. Water under pressure had forced the packed silt in the key trench apart, splitting it open the way fracking splits rock. Once that crack existed, the reservoir washed the core out through it. That's internal erosion, triggered by hydraulic fracturing. The panel's verdict on the design was the harder sentence. Defensive measures, like a properly sealed rock surface and adequate filters, were well within the state-of-the-art at the time Teton Dam was designed and should have been used. Not new, not experimental, known, standard, and skipped. Over the next 11 years, the federal government paid out around $322 million in claims. In 1978, Congress passed the Reclamation Safety of Dams Act, and the Bureau finally built the dam safety program it had never had. The canyon still holds both shoulders of the dam, standing on either side of an empty gap 50 years later. It was never rebuilt, so who kept filling it? The men who already knew the rock leaked, a schedule that couldn't wait for the outlet works, a safety limit that turned out to be a suggestion. The dam had been telling them the answer for 2 days. It ran out of ways to say it at 11:57.